let's start the next question. If a signal f of t has energy E, the energy of the signal f of 2t is. Okay, let's solve this problem in two dimensions. First, let me start with a graphical approach of solving this. Um, okay, I'm drawing uh, f of t, assuming some symbol signal, maybe a triangular signal. Let this be f of t. Okay, this is f of t. Let us suppose. Okay, then what is energy of a signal? We know energy of a signal is given by integral over entire time f square of t dt. Okay, so we have to find out the f square of t dt. So that may be something. I'm parallelly I'm drawing f square of t. So this is f square of t. Okay, the amplitude will be squared. So let us assume the signal is from 0 to t in the time axis, and squaring, this is f square of t, squaring the signal will not change its duration, only amplitude is changed, it's squared, right? So this is f square of t and f of t on the time axis. Okay, now the question here specifies to find the energy of a signal f of 2t. Okay, so initially let me draw f of 2t also. How will you draw f of 2t? Suppose this is t extrapolated to this graph. Here also t is extrapolated to this graph, and you can write t here and t here. Okay, and what will f of 2t looks like? F of 2t is the compressed version of f of t. You have to remember time scaling, right? You are time scaling f of t by two divisions. So I can draw f of 2t as something like this. Will be compressed. Okay, the amplitude will not change. I repeat, the amplitude never changes while we are doing a time scaling operation, right? Um, sorry, I have to write, or I have to draw f of 2t as half the width. Okay, compressed version means half the width. Okay, so this signal extends from 0 to t by 2. That is f of 2t. Okay. Now, what will be f square of t? I mean, f square of 2t, because energy of f of 2t will be equal to energy of f of 2t will be equal to integral over minus infinity f square of 2t dt. Okay, so we have f of 2t here. So what is f square of 2t? It will be a squared version of f of 2t again from 0 to t by 2. Right? It is 0 to t by 2. This is f square of 2t. Now finding the energy of f square of t and f of 2t. I mean, to calculate E, look at this equation. We have to find out the area under f square of t, because integral minus infinity to infinity some function of dt is actually equal to the area of the graph. Area under f square of t. Okay, so area under f square of t is I can denote by shading this graph. This is the entire area under f square of t. Okay, and the question is given as E. This value is E. Now, what is the energy of f of 2t? It is the area under f square of 2t, right? Area under f square of 2t. That means this area, and you can see the signal extends from 0 to t, and this signal without any change in amplitude extends only half width, right? Half width. So energy should be E by 2. Okay, so the answer should be E by 2. So this is a graphical approach to solving this question. And if you're so particular in knowing the mathematics behind this, let me clarify this. So we will give a mathematical approach to solving this question. This was graphical approach. You proved it or solved it. Now this is the mathematical approach. So energy is given by the minus infinity infinity f square of t dt. Okay, now what we want to do is we have to find the energy of signal f of 2t. Let me denote as e dash. E dash to be then equal to minus infinity infinity f square of 2t dt. Okay, let us follow this equation. Therefore, E dash is equal to I'm putting or I'm having a substitution U equal to 2t. I'm putting 2t as U. Therefore, I can differentiate that du equal to 2 into dt or dt is equal to half du. Okay, let it be there. Now we will resume calculating E dash. So E dash is equal to minus infinity infinity integral over minus infinity infinity f square, but 2t is given as u. So f square u into dt is given as half du. So half du. Okay. I can take the constant half outside the integral. So integral over minus infinity infinity f square u du, right? There's nothing wrong in changing the variable of integration to t, so f square of t dt, but this value, as you know, it is equal to e, right? So this is half into e. So the answer is B. And further, I would like to add one more tip here. So here we got f of t has an energy E. Therefore, f of 2t has energy E by 2, and we could generalize this. Generalizing this, so if a signal f of t has energy E, then f of at will be having energy E by a. So this is in the case of energy. Okay. And what about power? If f of t has a power p, then what is the power for f of at? Is it p by a or a into p? The answer is it is having power p itself. There is no change in power. Okay, so this could be a very useful tip for solving your case questions. Okay.